Hello everyone. So today the topic is very popular topic, very interesting topic in JavaScript, which is called closures. Though the topic looks very simple, but I see many times people out there, they are struggling with the basic understanding of the closures in, or let's say, variations of closures. With this closure session, I would like to emphasize that I'll be covering most of the important variations of closures which are possible in JavaScript. Also explain you what is closure, uh, and then try to correlate closures with the basic, I would say, real life analogy. So without wasting time, let me quickly go and start closures. Right. So what is closure? A closure is a feature in a JavaScript where we talk about inner function and outer functions. Remember, inner and outer functions, meaning function within function. Yes. So, closure is a feature in JavaScript where an inner function has access to the variables of its outer functions, even after the outer function has returned. Okay. Inner function has access to the variables of its outer functions, even after the outer function has returned, meaning outer function is gone out of scope. It has been returned, but even then inner function has access to the variable of its outer functions. And because of that, this allows the inner function to remember the scope in which it was created. All right. So this is closure. We'll see more in detail when we see the real code, different variations of the closures. But before we go, as I always follow the same philosophy, everything which we have right now on planet uh, technology world, on planet Earth in the technology world, is has been invented, has been created with real life experiences. So think of a closer as a hotel room key card. Okay, even after you have checked in into your room, the outer function has executed. Your key card, the inner function, retains access to your room variables in the outer function scope, right? So if you say that you see, consider hotel room key card, uh, let's say hotel room key card uh, is a closer. Then even after you have checked into your room, the outer function has executed because you checked into your room. The outer function is executed. Your key card, which is the inner function, it retained access to your room, meaning everything which is there in the outer function scope. Uh, we have many other, examples that we can understand with the for this closure. So let's say we are managing a bank account system. So closures allow create a private balance variables that can be only accessed and modified through specific methods. So we can have the closure concept there as well. uh, we could have closure, many closure example, but I would like to emphasize on some of the basic, I would say, compiled important core uh, code walkthroughs for closure, and we will understand how closure works in real way. Okay, so my uh, my way of explaining things is very straightforward and clear. I think it's important for us to see whatever we see in real is something our brain understand very fast, than even on listening. So looking it from your eyes directly gives you brain to interpret that. But when you're listening something, you add one more layer of complexity, right, which is translating everything that you listen and then tell your brain part of which things are, how you understand those things, right? Because every corner of the brain has a different function. So that is why I always prefer to have real time code walkthroughs or real time codes which you can see and understand. Okay, let's not waste time on this. Let's start with the question number one, closer word. JavaScript closure word. So over here you see we have an outer function and then we have an inner function also, line number 3. So closure mechanism here, how it works. The inner function keeps a reference to the count variable, okay, from the outer function scope even after the outer function has finished executing. So counter is outer, all right, this, and now you did counter 1. So this line number 10, it actually it has finished execution of outer 1, right? So line number 10, when you go to line number 11, it has finished iteration 1, or it has finished the execution. But this count variable will always be retained to the inner function. Okay, so when you run it one more time, so the count was 0, it was increased to 1, 1 will be printed, and then again line number 11, count memory value was retained, it was memorized by the inner function. Okay, and why it works? Because JavaScript function closures store a reference to the variables in the scope chain at the time the function is created. Okay, so let me quickly run this and see in real. So the question is closer. Okay, node closer q1.js. Here we go, 1 and 2. Let's go quickly to question number 2. All right. So question number 2 is counter with reset. All right. So what we are doing here, we are again creating create counter. All right. Increment. So this return here, we have two methods, return increment and then reset. And these two are inner functions, right? So increment. So, okay, returning an object with multiple methods, like we are returning an object here, okay, with multiple methods, increment and reset. It also demonstrates very important thing, which is how closure can manage a group of related operations on private data. You can manage, like closure are so I would say important. They play a very crucial role. You are managing with object, like multiple methods with, with returning an object. Okay, so this is how closures can manage a group of related operations on private data. Okay, so this count was encapsulated um, variable. It is inaccessible outside the returned object, making it private. All right, so this let is making it private. uh, so managing counters for specific task, meaning tracking task completed by user, is something which you can refer from this example. So if I run this, you see the importance of this. So increment 1, increment 2, because this will retain the value. All right, and then we are resetting it. So will counter reset will happen, count will be 0, and this is how exactly this will work. So I think pretty much clear. This increment is nothing but a closer inner function with closer scope, but closer scope. And then reset is another one which can also work, play around with this count. And increment these times we are calling it two times or multiple times, meaning returning the execution of this outer function scope. Okay, question number 3. So question number 3 is encapsulation with closures again. So the secret variable that you see right at line number 7 is a variable which stored privately. All right. I mean, this is a used created with const. Um, and you 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 call this my secret method here, which is calling secret keeper, and then you're passing JavaScript is fun, and it goes here secret JavaScript fun is passed here. Now you're passing this JavaScript is fun as an argument to this method, which is an outer function. uh, so now you have to understand. Let's say if this secret, let's say there was we have variable right. I mean, this is pretty much clear. This is this is visible to this inner function. But what about this? All right, which is passed in in a different way, like as an argument. So this is where the encapsulation work, right? So the secret variable over here, this is stored privately and only accessible through the relevant secret. Okay, through the reveal secret, sorry, through the reveal secret method. So this is only accessible through the reveal secret method. So console.log will print this when you get this. It will not be accessible, uh, I would say, to the outside world. It will only be accessible with the reveal secret method. All right, so let me quickly print this, see what it is output. Question with secret is JavaScript is fun. All right, so if I do it again, um, yeah, and run it again. So you see here, it's working perfectly fine. So this is only visible to this. Okay. Um, so next question is question number 4, which is now we have here called function. We can call it as a function factory, right? So what is happening? We are multiplier. Okay, so multiplier is a higher order function here. Okay, uh, that generate new functions like double and triple and things like that. So multiplier generate double function, multiplier generate triple function. So any function which is generating other functions, they are called as high order functions. Okay. Now you see here, uh, each generated functions retains the factor variable from its specific invocation of multiplier. So for example, multiply 2 when you pass 2. So this 2 will always be there. Okay. And each generated function retains the factor variable from its specific invocation. So 2 will be there. And then we multiply 3. So factor 3 will be there. And then what we are doing, because they will be retained, right? This is how this closure works. So this factor will be retained to this and to this. They will have reference somewhere memorized somewhere, this 2 and 3. And now when we do double 5, all right, when we do double 5, we pass this 5 here. So because the factor was stored, so 5 times 2 will be 10. And similarly here, triple 5 times 3 will be 15. And that's how it works, right? So question number 4, 10 and 15. So each generated function retains the factor variable from its specific invocation of multiplier. So this is very important concept. So I hope it's clear. Let me go to question number 5. Okay. Timer with closure. So what we're doing, we're creating let time is equals to 0, set interval. Uh, so the arrow function fast to set interval over here, the arrow function that we're passing, set interval, it forms a closure over the time variable, allowing it to update and log its value every second. Okay, it will form a closure every second. Anyone can allow this logic will allow it to update and log its value every second. So create timer, you just run this method. All right, so the moment you run this particular method, every second it will allow it to update and log its time. So let me run this. So you see here, time is 1 second, 2 second, 3 seconds. So every second it will keep on running. All right. And because this is set time and because this is set interval, and every second it will keep on running, and it will always maintain or memorize the time. And this is very good example. Okay. For creating live timers, for example, countdown mechanism, you can use something like that, which will always retain its value from the inner scope. So let me quickly cancel this because uh, this is not something which we want to go. Uh, okay, question number 6. Okay, partial, we can say it like partial application. So what is happening here? The partial function creates a new function. Okay, again a higher order function with some arguments pre-filled using closures to store the arguments. So from the outer function. All right. So partial function over here, it is creating a new function with some arguments pre-filled, and then using closures. I think they're using closures to store the args from the outer functions. So over here you are storing this from the outer function. All right, so what will happen here? So add, you pass a comma b is equals to a plus b, add 5. Now partial add function you passed, this is a function, all right, and then argument you passed is 5. Now this 5 will be remain, I would say, in memory somewhere for this inner function. And then now you passing add 5 10, which is the new argument you're passing in, all right, because the previous argument was args. Now you're passing this add 5 10, which will be representing the this inner function. You should, and then you, when you pass 5, so it will be 10, and then 10 and 5, these will be two argument will be passed to a comma b. So a is 5 and b is 10, it will be 15. So that's how it will work. Question number 6. All right. Uh, let's go question number 7. Event handler. So closures and event handling. The event handler function creates a closure over message this time. You see here, message. It creates a closure over message, ensuring it is available whenever the event occurs. So what we are doing, how we're generating the event. So let's say we are having a button, okay, on it, on somewhere on the document. So we are with JavaScript, we are kind of get element by ID my button, and then we are performing an add event listener, and then we say click it, and then we are saying it like event handler. We are adding an event handler this and button clicked. So uh, this message will be retained many times as you hit uh, this event handler, I mean this button. So question number 7, you see here it will not be reflected because we are not using any HTML. But yeah, if we just place this in an HTML file, it will be immediately reflected. So in your output. So that's how it works. So I can try to do maybe in a separate video when we play around with some HTML. So this is a very basic, like you need to create one div. I can just write something, for example, you will create body. uh, okay, so uh, let me quickly add an HTML file, test.html, and there we will say body. All right, and over here what we have to do, we just need to add div id is equal to my button, and there also you have to write script, and in the script you have to just write this all logic. Now yeah, so this is how you exactly, I do not want to go deep into this, but yeah, this is how exactly you play around with uh, any HTML code, and you can check all this, right? So my only purpose was to explain you this. Question number 8. Question number 8 is um, okay, now over here we're talking about, I think, private methods. Okay, so create function is an outer function. Again, it returns object which has get name and set name. Name is something which will be memorized by all the subsequent calls. So you pass ls here, ls here, ls is here. It will be memorized. Person dot get name will print ls. Then you set Bob. Then person dot get name will be Bob. Uh, because what you are doing, you have created an object. So okay, this is a very important concept. So the name variable is private here, okay, ensuring it cannot be accessed or modified directly, meaning when you create an object you need to have some getters and setters this way. So you create alias here, then you set override the name to Bob, so that's why Bob is printed. If I print question number 8, alias and Bob is there. Let me go to question number 9. Okay, so question number 9 is okay, so we have a loop with closure, of course. So var creates a single shared scope for all iterations. So I is final value is 6. Yes, i's final value is 6. And then set timeout, which will go into the normal task queue. A closure is created there, because you see here we have a function, and then inside that we have another function, and we are saying it's j, and then j is here. So what will happen then? So a closure is created for each iteration. For each iteration, you are creating a closure by immediately invoking a function this. So you are doing like immediately invoking that particular function that captures the value I. So um, let me run this question number 9. So you see here 1, 2, 3, 4, 5. So every 1 second, and then it will go till I is equal to 5. So 1, 2, 3, 4, 5. So this value is, I would say, retained, right? In all the, these are all like closure is created for each iteration. So for every iteration, there is a closure which is created. Um, and also at the same time, it is immediately invoked, uh, and which will capture the eventually capture the value of I. So I is 1. So over here, this I will be captured when you pass it to here, because this is j. So this I value will be captured. Next time it will be 2, it will be captured and will be printed, and then next time it will be 3, it will be captured and will be printed. And over here, just like difference in the, whenever you see the output, what delay you will see on the screen is something. Okay, so question number 9 is done. Now we have question number 10. Wow, it's memoization. Memoization is again the same thing, where you are memoizing some values. uh, One of the very core concept in dynamic programming, which I'll cover in lead code interview questions. So over here, what we are doing. So the memoization with closures is something where we talk about creating cache. So the cache object here is preserved between calls, ensuring previously calculated results are reused. Okay, so this cache will be preserved. This is an inner function. This fn will be retained, and this is a private variable which can only be accessed from here or any getter and setters, not any other outside. And this cache variable will be retained or preserved. So what will happen over here? We have factorial 3. We are memorizing. What we are memorizing? We are memorizing the cache. We are passing a function, and we're trying to find out um, this. First is calculating result, and then when cache first time when it will come. Okay, so function of x, which is 5. So x is equals to 0, which is not true. So in that case, it will return 1. All right. I mean, it is not, so it will return x into factorial of x minus 1. So it will calculate the factorial, right? Um, and then we call again factorial 5. So in this workflow, it will go to memorize, uh, execute this block, and cache of n will definitely be undefined. So it will print this for sure, and it will return the cache of n. And then the next iteration, when we do it again, um, the cache of n will be populated, because this cache of n was done in the previous iteration, and then it will print the cache of n values. So if you just print it, so it will print c, the final factorial. So calculating result 5, calculating result 4, 3, 2, 0, 1. So this is where you are only hitting this place. Okay, and then we got 120 after this 0. And once we got 120, we hit this in the cache. So cache n is undefined, and we say that okay, fetching from cache is there. So it will be fetched from the cache. So yeah, so that's pretty much all how it works. I think you got this. Like explain in detail if you want. Like this is a difficult part. of this question. So let me explain you in a in more detailed way how this function is working. So over here, this line number 4, we check if result is already in the cache or not. And if this condition is true, we say okay, return cache result. Okay, so cache is actually okay. I think factorial logic. Let me start from here. We do factorial 5. So we go to memoize wrapper, cache is empty. All right. At the start, check if 5 exists in the cache. If it doesn't, check if 5, which is 5, cache 5 exists. If it doesn't, logs calculating result 5. I think it's clear. So this is here. Now recursive call is there. All right. So calls factorial 4 because you see this is how it works. And then again it will print because cache 5 does not exist. It will print calculating result 4, then 3, then 3, 2, 1, and like that. So all these, like, it will go up to 0 and then return 1. Each recursive call calculates and stores its results in cache. So 1, 2, 3, they all are stored in cache. Now cache state after this call, cache will look like something like this. I will just add those numbers so that you're pretty much clear. So 0, iteration it was 1, then 1, 1, and then 2, 2, and then 3, 3, and then 4, 4, and then 5, 5. No, sorry, 2, 2, and then 3, 6, and then 4, 24, and then 5, 120. So this is how it's going to store everything into the cache after all this recursive calls are done over here. Okay. So first iteration, you will see this and all results are stored here. So it will be stored at like this. Okay. I can print you also this if you say, so that it's more clear to you how exactly it looks like. Okay. I can print console.log and cache. Okay, so you see here 0, 1, 1, 1, 2, 3, 6. So this is what I already show you, right? So this will print all like this. I remove this. And then in the second factorial 5 call, what will happen? Again, it will go to check if 5 exists or not. So because it was already there in the cache, so the second line number 19 will not calculate the factorial again because everything was there in the cache itself. Right? It will directly go and fetch, hey, cache n existed or not. If it is there, let's calculate the results straight away from the cache. So this is what is the purpose of memoization. It is a very, very important concept in data structures and algorithm also. I will put a link to the description of dynamic programming where this concept plays a very crucial role. Thank you very much and I see you in another video.